Okay, in this video we're going to do is we're going to go ahead and do the game loop. This is going to cover actually when the user is pressing the keys, what's going to happen. Okay, so what we're going to do is we're going to do all this code underneath here, all this code. There's a lot of code. We're going to do all this code. Actually, there. All this code as long as moving rocket does not equal stop. If moving rocket equals stop, it's not going to execute any of this code because it's not moving. Okay. So what this does, if keys down, this keys down command basically just checks to see what you're pressing. And if it contains 6, 5, 3, 6, 2, then this line of code, all this is saying is if the user pressed up. Okay. This is basically like a mouse up command, but it's a little bit different because it'll handle it in a function. No matter where we are, this keys down is special. This will actually handle the keys down wherever you are. So if you want to basically create code and not have its own handler, this is like putting a handler right in the function. It's pretty neat, actually. Okay, so if you're pressing up, what you're going to do is you're going to put the left of image blue gas into left position. Let me show you what's going on there. You're going to put the right of image red gas into right position. All right? If left position is greater than right position, you're dead. So what's happening is the right position of red gas is this. Right? It's the one underneath. Blue gas is the one on top. So what happens is, if the left position of the blue gas, here's the left position, right? We're going. Gets past, I'm just going to extend this window just a little bit. Gets past the right position of red gas, right here. Boop, it's passed. What does that mean? That means you're dead. You don't have any more gas left, right? So you're going, here's your gas gauge. We're going. Red represents empty gas, empty gas, empty gas. And remember, I resized the screen a little, so. And as soon as it does that, whoop, we're dead. So that is basically going to cover that. So as soon as the left position of the blue gas, which is here, gets past the right position of red gas, you're dead. So that's what's going on there. That's what this does. Right? And left position and right position we said a little bit later, but as soon as the left position is greater than the right position, again, the left position of the blue gas is greater than the right position of the red gas, you're dead. That means you don't have any more gas. That's it. And then we call this function called reset values. So let's go ahead and take a look at that. And here's reset values. It looks really similar to, again, pause the video and type that in. It looks really similar to start game values, except there's one little difference. You'll notice that when you reset values, you're putting 0 into gravity. You don't do that when you just start the game. You don't want to do that. That'll actually mess your game up. That's why I had to have two separate functions. So just take a second. What I would do is I would just copy and paste this to here, and I'll just make sure I put in the extra. Okay. Where were we? Okay. So this is, you guys get what this does now. This if statement, if I were to put this on a quiz and ask you what it does, you would just tell me if you see this. This is saying if the left position of the blue gas passes the right position of the red gas, you're dead. You don't have any more gas. If the angle equals 0, the angle, this variable, represents the angle of our rocket ship. So if our rocket ship's angle is 0, that means the rocket ship is just straight up and down. Put -1 plus speed y into speed y. What this does is this makes the rocket go up. Remember we talked about on the PowerPoint that if we go up, it's negative. So if we look at the code, when you put a negative value into the speed y, when you add a negative value to the speed y, that will make our rocket go up. So that's just saying if your rocket ship is straight, go ahead and do that. Now we're going to say if the angle is greater than 0. Now you should know from before, is that facing right or left? If you said left, you're correct. So we look here. Remember, it's a positive angle is right and a negative angle is left. We talked about that before. So let's go back to the code. If the angle is greater than 0 and the angle is less than 25. So we have we're basically breaking this up into 3 quadrants. We're going 0 to 25, 25 to 45, 45 to 65, 65 to 90, and then 90 to 110. We don't go above 110. You could, but we're just going to go, if you're over 110, it won't do anything. Right? It just it'll have no effect. Meaning the up arrow, if you hit the up arrow and you're rotated more than 110, it won't have any effect. So basically we have 1, 2, 3, 4, 5 different quadrants we broke the movement into from 0 to 110. So I'll just give you an idea of what that looks like. So let's say we have this. This is our, let's pretend this is our rocket here. This is 1. So the next quadrant would be like if it's between, here and there. 2. Let's be a little more. 3. These angles aren't exact, but 4. And then 5. So basically what you want is, based on this, you want to, if you hit the up arrow, it's going to thrust, it's going to make the rocket move up. Based on this, like, you'd want to have it go more this way. Like, let me give you an idea. Okay, you'd want to have it go more like that way, right? So we have to make sure that our x is greater than our y. It's just a slope thing. Now you're completely free to change these values. I spent some time playing around with these values and they look good to me. Like here, right? You'd want to go up more than over more. If you're all the way over, let's say there, like over here, say, you want your x value to be a lot higher than your y value. So that's why, let's go ahead and look at the code again. That's why we're playing around with these values. Like here, you're just saying if you're greater than 0 and less than 25, you're basically just putting in a speed y. You're not putting much in x at all. You're not putting anything in x, actually. Here you're saying if you're greater than 25 and less than 45, you're putting 0.2 into speed y and 0.06 into speed x. And watch what happens as the angle gets more, if we go back to our PowerPoint here. As the angle, this would be negative. We're doing positive. But as the angle gets flatter, watch what's happening to our values. So if you watch what's happening to your values, your speed y starts out high and your speed x starts out 0. And as you go down, you'll notice our speed x increases and our speed y decreases, right? By the end, we have all speed x and no speed y. So we're just reflecting those to make it go the right way. Again, this is all when we hit the up key. Now let's go the other way. So this is when it's less than 0. So now this is going right. Again, the greater than 0 is going left, and the less than 0 is going right. And again, this is based on the rotation of the ship. If you're between these two and you hit up, you'll go there, so on and so forth. So you can go ahead and pause the video for a minute and copy these values down. And again, I didn't use hardcore scientific data to create this movement. It just so happened I played around with these numbers and played around with these intervals and these values, the x and y, the speed x and speed y values, until I got something that I liked. Just know we haven't done anything yet with these, right? We're just changing speed x and speed y. We haven't actually done anything to the rocket yet. All right, so what we're going to do here is we're going to say put the left of image blue gas in the left position, put left position plus 0.5 in the left position. This is really important, this line of code. What this line of code is doing is as we're hitting up, it's moving the left position of our gas. It's moving the gas over. It's decreasing the gas. Right? It's moving the blue gas over and it's revealing the red gas. That's what that's doing. So basically, you're moving. If you're looking at the interface, you're moving the blue gas over as you hit up, and you're exposing the red gas. And again, remember, when the left position of our blue gas is greater than the right position of our red gas, you're dead. Okay, so that's what this right here is important. This is actually moving the gas. And then if you don't do this, set the position, the blue gas won't move. This is increasing its value, and this is setting the actual object on the screen. And this right here, We talked about before how it had two sub-images. Let me show you. So if we go to here, go to your property inspector. It's not coming up, but you have two images. You have this this one and the one with the fire. What this is doing, as you're hitting the up key, you're setting the current frame. That means the sprite. You're setting the sprite of the rocket image to number 2. It starts off at 1. That's the first frame. That's the one without the fire. And 2 is the one with the fire. Okay, that's all there is. That's why you're getting the fire. What this is doing, if keys down contains left, you're just simply going to go ahead and rotate it left. And again, remember I said when you add a positive number to the angle, it rotates it counterclockwise, which is left. And if you don't set the angle of the image, rocket image, to the angle, this is actually what's moving the object. So this is changing the value, and this is what moves the object, right? You're saying set it to the angle, and the angle is this, which, like, for example, the way this would work is if I hold left down, the longer I hold left, it'll just keep increasing. It'll keep adding 4 to the angle. Remember, you could always say add 4 to the angle, right? You could always do that too. This is right now if key contains 65363. You don't have to memorize these. I found them online, so it's not necessary. And here you're adding -4. So if you're pressing right, you're making it rotate right. And again, to make it rotate right, you have to add a negative value. Now, why did I choose -4? Because it looked good. I could choose -2. You could try -1, -10. You know, it's up to you. What you're doing here is if s speed y is less than -2, then put -2 into s speed y. So what this is doing is if your speed is less than -2, it's just going to top it. What do you call it? So like let's say if the user's holding down the up key for a while, you don't want the speed to get crazy fast going up. So this will limit the speed to -2. You can even limit it to -1 if you want. You can try that. This will limit how fast the ship. This statement limits how fast the ship moves up. If you make this -1 and then put -1, just make sure these match. This would make the ship move up slower. Okay, so now we're going to call a couple of functions. Move the ball. That's just me being silly. It should be called move the rocket. Collision, you're going to check to see if it hit anything. And send the game loop to me in 1 tick. This is important. What this does is this pauses the code here for 1/30th of a second, but allows the other functions to still run. So the rocket can move around and do its thing, and you need that at the end of every game loop. Just know when you make a game, you always have to put this line of code in. So you can have things in the game moving besides your player or what have you, and it'll still work. Okay, so that's important to understand. For this particular game, you might be able to get away without putting this in, but we're just going to put it in here anyway. Okay, and this ticks determines the speed of the game. So if you were to put like 10 ticks, it would make it slower. So that's the end if means, remember, way at the top. We said if the moving rocket does not equal stop, so we're just ending that. That whole thing was for that. You could probably move that up a little bit. Oops, we'll do that. Okay, and that ends the game loop. What we're going to do in the next video is we're going to go over this. We're going to go over what all this stuff means, checking the collisions. Okay, that's what we're going to do there. That ends this video.